Okay, hi everyone. Now, this is my video number 12. Now, limit and continuity. Limit and continuity. This is more or less just refresh from what you have learned earlier in the previous subject, I think. So just go through this thing. Give a definition of limits. If now we say limit of a point xy approaches some, let's say x0, y0 for two variable function, this equal to L if given any epsilon positive, you can find delta positive such that the distance between those point function to the limits much less than epsilon. For wrong those point xy in the domain of function, or I might say, or I might write something like x minus x0 minus less than delta, y minus y0 less than delta. Okay, I give you example for this. I think I have two example. First, how to apply limit directly. Limit. Okay. Let's say we have going to find the limit of xy approaches 0, 0 for the function x squared minus y squared over x squared plus y squared. Okay, so the purpose, we have a, for example, we have a point x0 here, x0, y0 there. So we need x, a point xy, so which means this point xy approaches not from any direction, so you can choose any path, and you have to make sure that if the limit exists, xy approaches not at any direction, will give the same value. Right. So for this example, let's consider x approaches 0. Here x approaches 0 along, I can write like this. Let's say along x-axis we have y0. Alright, so what happened here, you take a limit, what happened along y0, so we have a limit x along y0 approaches 0, 0 of those functions, what we have x squared over x squared, that give you 1. Okay, and then that's along x-axis. If you consider along y-axis, no, along x-axis means here, that. Okay, as long as we want to approach that point, we can also approach from y-axis. That if you consider along y-axis, which our x is 0. So what happened here, y is 0, so we have limit our x is 0 along y-axis to the 0 0, what left is minus y squared over y squared. That gives you minus 1. So you can see here the limit approaches 0 0 from different path, give you different solution. So which means in this case, based on this case, this is minus 1, sorry, based on this case where the limit doesn't exist, limit for this particular example. Alright, that's the first example. For the second example, I would like to use the definition of limit here. Okay, so which means you need to find function that the limit exists. Alright, show that the limit xy approaches 0 0, 3x squared y over x squared plus y squared equal to 0. So we use the definition, given any epsilon positive. So we have the difference between function, which 3x squared y over x squared plus y squared minus the limit, which is 0. Then we want to show this less than epsilon. Alright, we want to show that less than epsilon. Okay, so that part we have 3x squared y over x squared plus y squared. We know that when you take the absolute value, which means we only consider the positive part. Okay, positive part. So what happened here, x squared is always positive, x squared is always positive here, this is always positive. What left is only y. So we have, in this case, I can consider this as a 3x squared y over x squared plus y squared. Okay, remember that you want to show this is less than epsilon. You want to show that less than epsilon when the distance x naught y naught less than delta. Okay, so if we take that, we know that x squared is always less than x squared plus y squared. Why? Because this one is always positive, x squared is always positive, x squared is equal to x squared, and y is always positive. So which means the right hand side here, this is always bigger than the left hand side. Yeah, y squared is always positive. So if we divide those things, bring it to the left, so we have x squared over x squared plus y squared, they will be less than equal to 1. Okay, then if you multiply here by 3, you apply the negative y, you can do the same on the right side. So we have 3x y squared y over x squared plus y squared. This is less than 3y. Okay, what we did here, we just multiply by 3 and multiply by magnitude y, left hand side of this equation. Why do we do this? Because from this expression we can show that the difference between function and the limit can be written as that part. So we have this term here, and this term is now similar to that terms. So we know that this is less, this term should be less than that value. Okay, So for 3y, magnitude of y, this is less than 3 third y squared. Okay, and this is surely less than I think this is equal. Alright, this is less than 3 y squared plus x squared. Okay, what about this? This is the distance between point x and x naught, y and y naught, which is delta. So therefore we can choose, I think you go to next page. Choose delta epsilon over 3. So therefore we have everything in the bracket there, 3x squared y over x squared plus y squared, that less than epsilon for all x squared plus y squared less than delta. So that's the proof. Now on the continuity, I won't go detail on this thing. I just give the definition of the continuity. What's the definition of this? Just extend from the single variable function. If you're given, we say a function f xy is continuous at point x naught, y naught, if the limit of that function xy approaches x naught, y naught, f xy, this is equal to f x naught, y naught. So if our function satisfies that condition, the existence of the limit, and then if we evaluate the function at that point, the value is same, then we say the function is continuous. So I think enough for the limit and continuity. Thank you.